Here we go. So let's do a quick review, and I'll send this notebook to y'all. So we're talking about encoding variables, when to encode variables, which variables to encode. We'll talk about scaling variables in a little bit. But for right now, what we're doing with encoding is we are encoding strings. We're encoding categorical values and turning those into binary columns. So got our handy dandy decoder ring. And when you decode the message, obviously, be sure to drink your Ovaltine. Right? But this begs the question, when do you use encoded data? When do you use unencoded data? And I'm going to give you the quick answer right now. The data exploration process is going to make more sense in English, right? In strings, rather than in those binary columns that you get after one hot encoding with the get dummies. So explore your unencoded data, model, always model on the encoded data. Same thing with scaling, but we'll get to scaling later. So in the interest of making a simplified notebook here, I have some very clean data. I'm going to import pandas, Seaborn, the Pi data set, stats library, train test split, and a decision tree classifier classification report. And then I've got my handy dandy train validate test split function here. The data set that I'm going to be working with for this specific notebook is the tips data set. It's got some numeric columns, total bill and tip. Those are continuous. And then our categorical columns are the gender, smoker status, day, which is Thursday, Friday, Saturday, Sunday, and time, which is lunch or dinner, and then the number of people at the table. So the nice part about this data set, it's squeaky clean. We don't have to clean data types or do anything there. There are also null values are missing, which is great. We don't have any nulls to handle. So at this point in the game, we want to handle any nulls if they were there, clean any data types if we need to, but we're good. So what's the state of the data? Data types are good, no nulls. I have 4 categorical features. So I'm going to introduce y'all to the dictionary definition, data pre-processing. Data pre-processing is the part of the prep stage that is encoding, that is scaling. This is getting the data into numbers so that your model can talk to it. You can do data exploration all day long without data pre-processing, right? All day long. Statistical tests, as long as we have the nulls handled, we can visualize, we can run stats tests, etc. So I've got a little bit of programmatic code here to pull out only my categorical columns. I'm saying for column in the list of the data frames column, if that specific column's data type is object, then return that so that I then have a list of the categorical columns, right? So this whole data pre-processing is separate from the data cleaning. It's a separate process. And a lot of, in our curriculum, we say that the pre-processing is part of the data prep. It usually is because we want to encode everything at one step. I'm happy to tell you, there are practitioners who encode their data the minute before they model. They don't worry about it when they're cleaning the data. They don't worry about it when they're exploring, but they do the encoding right before they model. That's their process. So I want us to marry ourselves to this idea that data pre-processing, while we've introduced it in the prep stage, that's not the only way to do things. And I'm not trying to introduce uncertainty to throw y'all for a loop, but I want to introduce an idea of certainty in that data pre-processing can happen after your exploration. That's totally legit, right? Because it's a lot. If you're wading through the muck of cleaning your data, you might want to blow off encoding it until the data is clean, right? You probably should. Mindy?
Just save time before you split.
Yeah. That's what we do. That's why we introduced the data pre-processing before the split in the curriculum. Yeah. But in case you're talking to a colleague on the job and they do the data pre-processing, the scaling, the encoding after exploration, they're not wrong. They're just different. Yeah. Same thing here. You're not wrong. It's just a different way of doing things. So there's 2 ways of handling our encoded and unencoded values. It's really up to you how and when you want to do things. My advice is to pick one method and roll with it and stick with it. Don't bounce between these two or you're going to get yourself confused. Here are our options. One option is not better. One option isn't worse. They're different. But they're the same, right? They're functionally the same. The code changes a little bit. So let's talk about our first option is make one big honking data frame of the unencoded values and the get dummies, where you concatenate the get dummies on. And this is what we suggested in the data prep lesson, right? So we're almost all the time going to explore unencoded data. And it's simply because it's easier to visualize. It's easier to run stats tests on. Frankly, the encoding only exists for models. It doesn't exist for human beings. Why does the encoding matter? Well, because models need encoded data. Models don't talk strings. Even machine learning models that work with strings are talking to numeric representations of those strings. So that's one option, is to make one big honking data frame, and I'm going to show you all the code implementation of doing that. Option number two, again, these are exclusive of each other. Pick one, roll with it. Option number two is to make two different data frames before you split, where you have one data frame with all of the encoded values and another data frame with all of the raw values. And they're still cleaned and you've handled your nulls. So one data frame for exploring, one data frame for modeling. Again, not a huge, no difference at the end of the rainbow, but it's up to you which feels more natural. So we'll talk about option number one big honking data frame for everything. So the thing that we do here is use get dummies on the encoded values to produce a dummy data frame. And then we'll concat that dummy data frame back to the original data frame. And then we'll split into train, validated, test. And on that big honking data set, we explore unencoded values just by their column names. We talk the unencoded values, but then we model on the encoded data frame, on the encoded values of the data frame. So let's take a peek at this. I've got my dummy data frame. Notice how when we had a binary like smoker or not, a binary column, once you do get dummies, turns into two columns, right? So if your column had 4 options, you get 4 columns of binaries. That's what get dummies is doing. And it's because models talk ones and zeros. They don't talk Friday, Saturday, Sunday, okay? This is called one hot encoding. The one hot means that let's take a look at the days, Friday, Saturday, Sunday, and Thursday. Only one of those values is hot, as in turned on, as in like the hot part comes from electrical engineering, right? A circuit is hot when it's complete. Yeah, I saw a question from Ryan Miller. Go ahead, Mr. Ryan Miller.
Hey, thanks, Ryan. Quick question. Why didn't you drop the first this time when we've been doing that? And that's something that still kind of confuses me. So maybe your answer will help me with that.
It's because I'm purposefully trying to confuse everybody.
Okay.
That is not my goal in any way. The reason I'm not dropping first here is because I want to focus on other things.
The day it really doesn't matter once you get to the modeling, because the modeling knows that there's a third option inside, hidden inside the data. Okay.
Sure does. And what the drop first is doing, I want to review and repeat this. When we have like two variables in a single column, like gender had 2 and smoker had 2, the drop first means one of these 2 columns goes away. That's all it means, is it's reducing some duplication. So when I turn drop first to true here, the sex male, sex female drops down to just sex male, because it's a binary between those.
That wouldn't mess up your decision tree, would it? Like having both columns?
No. Yeah. I'm certainly open for other clarifying questions on the drop first, if y'all want to talk about the drop first. But if 2 columns are inverses of each other, the decision tree will figure that out very easily. Cool. Do you have a follow-up question, Ryan? Are you good? Cool. So We can drop first, we can not drop first. Now, when I concatenate those dummy variables, oh, I have a question from Kate. Go ahead, Kate, whenever you're ready.
Yeah, I just saw Jen post it and I'm kind of thinking the same thing. Is there a pro con to dropping first? And then in particular, my thought is for things like decision trees, I would imagine you're creating like a duplicate attribute that
Yeah,
might eat up your decision tree depth.
yeah. So are there pros and cons? The pro of dropping first is that we've reduced some duplication, and that is helpful in the binaries, right? It's not immediately helpful for human beings when we have multiple options, however. So this is a con. I have Saturday, Sunday, and Thursday, but I have to write down and remember that Friday was another day that they were open, not Monday or Tuesday or Wednesday, right? So that's kind of the downside to dropping the first, is with categories with multiple outcomes, you got to write it down and think about it, right? Because if something's not Saturday, not Sunday, not Thursday, it must be that fourth option, which we then have to consult our notes about.
So
Yeah, no.
decision tree that easier, because I know this, we're not just talking about something so much, but it will be split, and if something's included as like one, let's say it would go to say like less than 1.5, or so then you're kind of like thinking.
Yeah, you don't have to worry about what those numbers are. And the decision tree focusing on greater than 0.5, that's because your two options are 0 and 1.
Right. I guess I mean, like, if you had both of those columns instead of dropping one, then would it focus more like clarifying?
I don't see that there would be any issue with the decision tree there, because they are exact inverses, not even a rounding error anywhere. Yeah, I don't see how a decision tree would have trouble with that specifically, but we'll talk about another pro of dropping the first is the more columns you have, sometimes the more columns you have, the harder it is for the model to do good work. And the term for that is called the curse of dimensionality. So if we had 1,000 columns, one of those columns isn't going to have too much of a bearing compared to the other 999, right? So lots of columns can muddy the waters. They can make predictions harder. Yeah, essentially, yeah. Right here, we're in the handfuls. I'm not worried about the curse of dimensionality here. Another thing on the curse of dimensionality is, yeah, if you have each column you add grows your computational need exponentially, which with these data sets I'm not worried about. But on the job, you have something huge. Too many columns may mean that you're not able to run the model on your laptop. Right? Yeah. Kate, did you have a follow-up question?
Yeah, and maybe I missed it because it's hard to hear people in class, but if you don't drop first, and let's say for Titanic, that gender is the #1 indicator of whether or not you die. And then the second one is age. If we don't drop the first, and we only do a depth of 2, the first 2 should be sex female, sex male, right? So we kind of we have to add more depth in order to get a meaningful change in the outcome.
No, I'm going to make the argument that, and we can find out if I'm incorrect or not, but we have 0 difference in information if we have 2 columns that are completely inverse of each other. Andrew has a comment?
So if you split what is male, asking a question is female on the second would be useless because they're all going to be female.
Correct. Yeah. Yep. Yeah, I'm not, I feel like y'all are focused on the drop first a bit too much. I'm not trying to get into that right now, but I want to answer your questions. I'm trying to talk about the encoding. This is the first step of encoding. But right now, let's just say this drop first has 0 benefit, dropping first or not dropping first. I actually just want to get to some other stuff if we can. Yeah, are we cool? Cool. So I'm not dropping first. I am dropping first. The punchline is that we're encoding the data, right? And then I've concatenated everything together. One big honking data frame, total bill, tip, and then see how I have the original unencoded values still. Sex, smoker, day, and time, size as well. And then I have all of our binary columns out for that one hot encoding. Okay, so I hope the discussion on the drop first was valuable to y'all. The big question is, what the heck do you do with your encoded values? That's what I'm trying to get to here. So when we have one big data frame, what we're going to do is explore the unencoded values. Well, let's talk about that. Unencoded values are easier for charts. They're easier for statistical tests because each column is one variable with multiple outcomes, not n number of columns that are all binary. That makes it hard to visualize. Let's take a look at the chart that I have on the screen right here, for example. I've got a scatter plot where my X is total bill, Y is the tip amount. The hue, the color is the day. So and then the column is time. So the left-hand subplot is dinner. The right-hand subplot is lunch. And we see on lunchtime, it's mostly Thursday lunch. And there's a little bit of Friday lunch here, a little bit of Friday lunch, but there's no weekend lunch, right? So conceivably, if we are trying to predict the time, we might have some good indicators of if we're trying to predict if a given customer is lunch or dinner. When we look at the dinner, we have, very interesting. We have Saturday and Sunday everywhere for dinner, a little bit of red. So some Fridays in there, 1, 2, 3, 4, like 7 Fridays in there maybe. Okay, so this right here, my friends, is why we explore the unencoded data. Because imagine we have 4 days. Even if you do the drop first business, you still have 3 columns that are binary. Then you have another column that's binary. How are we going to visualize this? We can't, not with Seaborn, not this easily. Right, so explore and then do your statistical test. So I'm going to do a statistical test. Let's say I'm trying to predict the time. So time is my target variable. I'm going to run a chi-squared test and run a cross tabulation between smoker and time to see if there's a relationship, the evidence of a relationship or evidence of no relationship. And what we find is that there is insufficient evidence to reject the null that they're the same, that smoker and time are independent of one another. So we move forward with the understanding that smoking status and time are independent and have no relationship. That p-value is way high, right? So we definitely do not reject the null. Questions at this stage in the game, folks? And a reason why I want to talk about this chi-squared, man, why are we going back in time, Ryan? Well, we run statistical tests to inform us on what our features might have a relationship to the target. That's why we run statistical tests. That's why we make visuals. That's why we do exploration, is to get to know the drivers. Then we build our models based on the drivers rather than based on things that aren't drivers, right? So let me check and see if we have any questions. Okay, cool. So at this stage in the game, I have one big honking data frame for everything. So I've manually focused on what columns I do a statistical test on. And I've manually focused on what columns I visualized. So far, so good? Cool. So now that we've, I don't necessarily want to, oh shoot, I'm a bad person. I should have split my data into train and test before exploring. We should be exploring train. Let me move that. There we go. Cool. Okay, let me start this over. I don't want to give you a bad example. The data science police will come for me on data science warrant roundup day. Okay. So I'm producing dummies on everything to encode everything. I'm splitting before I explore. and then I explore only train, and I run statistical tests on only train. Okay. So now it's time to get into a little bit more of the data pre-processing. Encoding our categorical variables is pre-processing, but also splitting our X and our Y is pre-processing. You don't need the X and your Y for exploration. This is only necessary for supervised learning algorithms, the X and the Y. Okay, so let's take a look at what we've got here. I'm going to let me take a look at train real quick on its own. And also we have the variable categorical columns. Okay, so I have the categorical columns of sex, smoker, day, and time. And I am specifically deciding that time is my target variable. And I'm noticing something. So in my X, I'm going to drop all of those categorical columns, but time is still part of the encoding here. I probably shouldn't have encoded the target variable. That's not necessary for trees. Encoding your target variable is necessary in some classification algorithms. We'll get there later. So I want to drop my categorical, my unencoded categorical features. I also need to drop lunch and dinner. So let's do that. I'm going to append time dinner. And then I'm going to append time lunch. And we'll take a look at that categorical column just to double check everything. So it's unencoded values, and then it's also the encoded versions of my target variable. Okay. So what I'm going to do here is I will drop from train, I'll drop those to get X train, and then I'll peel out time to give me Y train. Fred?
Where you drop it,
No? What are we, so
when you're just setting it up for labels.
yeah, so I want to drop time, but see how we're peeling Y train off of train.time? After I split train into X and Y, I don't talk to train anymore. Is the answer to your question. So I think your intuition is correct. That we don't want to have the target variable in what goes into the model. But in this case, the drop here is not mutating anything. It's giving us back a copy of those dropped. So let's take a look at what we've got. We've got an X train and a Y train. Again, splitting your X's and your Y's, necessary step before modeling. So we call this data pre-processing. Just like encoding is data pre-processing, just like scaling numerics that we'll cover next module in regression is pre-processing. Not the same thing as cleaning, but often talked about in the same space. Okay. Is this helpful so far? Is this a good use of y'all's time? Okay, okay, groovy. So let's take stock of where we are. We have total bill, tip, number of people. I didn't drop the first, so I have 2 columns for each binary. Smoker is a yes, no, so, but since there's no different information, I'm not expecting anything crazy there. And then I have the day. The good news is I don't have the target variable in my input into the model. Let's talk about baselines. If I'm trying to predict time, what I'm going to do is get the most commonly occurring time. The baseline is your best guess. The baseline could be the mode or the median or the mean, if you're talking continuous numbers, or the baseline could be what the business has always done. That could be the baseline. Our job is to try and beat the baseline. If there's any value to predictive modeling, that value comes in doing better than what's already there, right? So I'm going to make my baseline. The baseline guess is to guess that every customer's dinner. And when we run the accuracy, which is df time double equals baseline, get the mean and round it to 2 decimal places, we see that if we guess dinner, we're right most of the time, but we're not right all the time, right? So far, so good? Questions about baseline?
You get a baseline of the entire data of the train.
No, this is a mistake. You get your baseline off of the train. Yeah, because we don't know, if we're stratifying, it shouldn't matter. Yeah. But yes, thank you for catching that. Once we've got, oh, go ahead, Lincoln, question.
Hey, Ryan, if the baseline is too close to, let's say, the mean or like the mode, in this case, like, how should we handle that?
The easiest thing to do with categorical is use the mode, because median is meaningless with a categorical outcome. Same thing with an average. We'll talk about mean versus median in regression, if I can hit the snooze button.
Okay, perfect.
Yeah, again, your baseline could be the mode. Your baseline could also be what the business has already been doing, right? Baseline just means the best guess so far. Yeah, let's see, Jason is asking, what if 2 variables are tied for the baseline? If we have a bimodal, just pick one. Yeah. And if, like in the iris data set, you had even numbers of all 3 species, just pick one. And move forward. Cool. Y'all ready to make a model? All of this work, and it takes 3 lines of code to make a model and fit a model and then use the model, right? So I'm going to make a decision tree. I'm setting max depth to 3. This is why I'm asking it 3 questions. I want to know, okay, let's try to classify if somebody's a diner or a dinner customer or a lunch customer. So we make the tree, we fit the tree, we use the tree to make our predictions. And then the classification report takes in the Y actuals as the first argument, and then the Y predictions as the second argument. So this is training data right now. And we see, wow, 99% accuracy. Now, we want to double check, did we use any time features? Did I accidentally left a time feature, an encoded time feature in, so my models were giving me 100% before. But this kind of makes sense on the time. We saw visually that the time, you could, depending on the day, not necessarily the tip or the total bill, but based on these other features. And I didn't even visualize smoking status. Smoking status may be impactful as well. So I've got a pretty good model here. Works pretty well on in-sample data, the train data. Now, in order to evaluate on validate, I'm going to talk to the original model. You never retrain your model. Your model always trains on train. You never train your model on anything else other than train. That's why it's called train. So I'm going to say model, make predictions about X validate. So this is going to get our list of predictions, and I'm going to produce Y validate, the actual answers, and I'm going to send in Y validate predictions. And okay, we're a little bit overfit. The out of sample data, we're not doing 99% accuracy, but I'll tell you what, 95%, 99% accuracy, those are beating baseline by quite a bit. Okay. So if baseline was 72, percent improvement, so we'll say baseline accuracy is 72. And if we say validate accuracy is, 0.95, baseline accuracy is 0.72, then we can say the difference is validate accuracy minus baseline accuracy. And then we can calculate this percent change as the difference over The original. So it's not just the number of percentage points, but relative to 95%, moving from 72% to 95%, we have a model that's about a quarter better. It's really good, really good. So take away from our model, we have a pretty strong predictive model for predicting if a table is going to be lunch or dinner based on the size of the table, smoking status, gender, total bill, and tip. And what I've shown y'all right here is doing everything on one big honkin' data set, data frame, with unencoded data and encoded data, but we are strategically dropping the encoded columns. I don't want those encoded columns, the unencoded raw columns rather, excuse me. I don't want strings going at X train. X train should never have strings. Y train could have strings just because it's the target variable. We don't always need to encode the target. Okay, cool. Yeah, I see a couple of people raising hands. I see a question from Jen. I'm not sure who else. Go ahead, Jen.
Yeah, so just at this point, I mean, this is great. Thank you for showing us kind of the workflow because this is really helpful. At this point, let's say that you want to go back and do a little bit more exploring. We can always go back because even though it is in one big data frame, we still can go back and explore because we still have those variables in the unencoded.
In train, that's right. Yeah.
In training, yes.
Because my X train and Y train did not destroy my original train. So yeah, we could just scroll back up here and do more stuff. Right?
Okay.
Yeah. We could do total bill, tip, and instead of time or instead of day, we could do gender, right?
Okay. Yeah,
and
that's
trying to determine if there's a different gender distribution on a given dinner or lunch. Yeah. And,
okay.
and this is all because the original train never got messed with. Here.
Right. And then the second question for this is like all the way up until the point that we're starting to explore when you were talking about, or no, even I guess at the point where we like split our data, that still is within like the prepare.py like files, right? We did do that in our files of like kind of going up to that point.
Yeah, I did encode everything. So I didn't have to run get dummies 3 times.
Yeah.
After the split. But you'll notice once I get that one big honkin' data frame together, next thing I do is split it in a train test split.
Okay. And then I was just going to ask, sorry, I'm asking a lot of questions, but it's
Please
helpful. But so for you personally, because I know everyone will do it differently, when you're calling in, let's say that you've done all of this in your prepare.py file, for you, how would you call in this then? Are you calling in like at this point, are you calling in starting here on line 8? You say train test, and then, well, no, I guess you wouldn't say that, would you? I think I'm answering my own questions. This is good.
Yeah. Let's say if I'm importing things, what I would do is import prepare, and then I would do train, validate, test. And I want to put these in comments because I don't have a prepare function in this folder.
Yeah.
But we would do prepare dot clean and split on DF.
Right. And because we've already done it. And then that whole train test valid. Okay. Because I always get that tuple thing. I think I showed you that yesterday, the tuple error. And it's because I'm not having that in my Py file. Okay.
So all of the work that I did before, so if I encoded, and this is why I appreciate y'all making some time for this going off road here. If we're encoding as part of the prepare script, that's totally okay, right? But we need to make sure that, you know, once you've got your train here, that it is what you think it is. Right. And I have a little more to do because I still need to drop those encoded versions of the target variable. The name of the game is keeping your head on straight and writing things down. That's really the name of the game. I'll say all the above code could be inside of your prepare.py. Might exist in multiple functions too. Cool. Thank you. Thank you for your questions, Jen. Did you have any other follow-ups? Cool. I think I saw Arsene. Arsene, go ahead whenever you're ready.
Yeah, my hand dropped because I clicked on the wrong button. Sorry. If I want to summarize, basically, if I don't want to encode my data right before I model it,
Yeah.
then that's how I should go with it, the way you showed here.
Yeah, the code that I've shown you here would be, yeah, you would encode inside of your prepare script is what this is presuming.
Thanks.
So to recap, what we did for option 1 is we made one big honkin' data frame for everything. We used get dummies to encode one data frame in one swoop. Then we split the data into train, validate, test. We explored unencoded data because it's easier. It's actually like possible to run chi-squared on unencoded data. You would have to, if you wanted to run a chi-squared test on 4 encoded columns, you'd have to take those 4 columns, turn them into 1. So you'd have to undo work, right? So I've been fielding a lot of questions that are all kind of related, which is why I put this notebook together for y'all, and I'll be sharing the code for it sharing the code for this in moments as soon as we're done. So you can do the one big honkin' data frame. The thing to remember is not if, but when you are dropping your columns for X train, instead of just dropping the target variable, you drop the encoded columns also. And if you had any encoded versions, this is important. If you happen to have an encoded version of the target variable, better get rid of it. Because then you're going to have a model that's predicting 100% accuracy all the time. That's because it already knows. If the input is actually the target variable, you'll always have that. Okay. Would y'all like to see a different method, or do y'all just want to live with this one method? Okay. I don't have a preference, and there's not an industry preference. I will do one big honkin' data frame half the time, and then I will make 2 data frames another time. So let's talk about option 2. Option 2 is to keep keep an unencoded data frame for exploration. This is your train, right? Data frame for exploration, and then another data frame with encoded values for modeling. So let's take this from the top and let's work through this a little bit. So I'm going to get my raw data from the tips data set. I'm going to isolate my numerics, and then I'm going to encode all of the categorical values. Notice, now I learned, if you can believe it, we're not encoding the target since we don't want to encode the target. Okay, so I have encoded gender, encoded smoker status, encoded day. That's it. Now I'm going to concatenate that with the original data frame onto encoded DF. And my thought process here is, let me find my little train test split here. There we go. We always need to split our data before exploring it, right? But we can do the following. Time to split, we can make an unencoded split. And I'll show you what I mean by that. So I have 2 things. I did this maybe a little fast. I said, hold on to the numeric columns get dummies on the categorical columns. So we have the categorical columns, and then this PD concat here is saying concatenate together the dummy data frame and only the numeric columns from the raw data frame. Questions about what we're seeing with this encoded data frame?
How should we like to save time?
Yeah.
Would you, that after, like if you wanted to work with smaller data frames, so if you have your large data frame, split it, and then just call one of them like explore one of them model, you know what I mean? No?
Oh, you mean the variable names?
Yeah.
Yeah.
Like, but after you split.
You could, yeah. Yeah, you could. You can name those whatever you want. I'm gonna name one encoded and the other not. I'm just gonna prepend encoded DF.
I was just thinking, like, would it make it like almost for a single, I guess you would have to do it for all three if you split.
Like down here, if I'm splitting the encoded data frame, then I'm gonna make encoded train, encoded test, encoded train, encoded validate. So, and then let's see, encoded data frame, I stratify on df.day. That's interesting. I didn't leave day in here, did I? So I can't stratify on something if it's not in there. Let me add this over. Okay, I actually do need to put time in here. Let's take this from the top. Raw data, numeric columns. And actually, I don't need to encode time. But what I'll do here is, because I need time, the unencoded time for the target variable, I'm going to include that as part of the concatenation. See what I'm doing with this data frame? I'm concatenating 3 data frames together. So now you'll see time on the right-hand side. So the encoded data frame has time. I'll peel this off as part of the XY splitting, not the train test split, but the XY split. And so my target is day. My target is day. Train is no longer train, it's encoded train. And we'll check out encoded train.head. Whoops. Let's see, found input variables, input consistent number of samples. Oh, it's this right here. I'm still stratifying on a train.day encoded. Object, data frame object has no. Let's try running this again. Raw tips. Let's see, this is bombing out on line number 4. Really in a stack trace, unless you are the author of a library, the first line of a stack trace and the last line of a stack trace tell you where the problem started and what the problem is. So this is telling me, so a little bit of debugging, right? We're going to break this out into 3 different pieces. We'll say, run the data, raw data, do the concatenation. We should stratify on the encoded data frame.day. That should help. Oh, I'm typing day. I keep thinking time, but I'm typing day. Excuse me. My target variable was time, wasn't it? Well, that explains everything. I kept typing the wrong column. There we go. Okay, cool. Wonderful, wonderful, wonderful. To recap, I was making a boo-boo because I'm a human being, if you can believe it. All right. So we still need to peel out our X's and our Y's from here, right? And I still need to do the train test split for the unencoded data, right? So the nice part about that is I can steal from myself. If you can't steal from yourself, who can you steal from, right? So now we have unencoded data. And this begs the question, what do you, straight ahead, what are you going to do? Well, folks, explore un-encoded data. Run stats and visuals on un-encoded data. And so here we'll do SNS dot rel plot, total bill, tip, Q could be day, and column could be our target variable of time, right? So we are, it helped if I send in the data frame here. We're going to send in train. So notice we're exploring un-encoded data. And that's because you could put this chart in front of a stakeholder and they're not going to ask, what the heck is Friday? And then we can do our statistical tests on the unencoded data. But are y'all with me? We can pretend we're doing a lot more EDA right here. Okay. Now it's time to model. We'll separate. I'm not going to say split. I'll say it will separate the X and Y values. And here, what I'm going to do is steal for myself again. But notice what I'm going to do here. Let's see. The dropping. Now, when I look at what needs to drop from encoded train, it's not a whole bunch of other columns that we had to make mindful note of. It's just the target variable is time. So from encoded train, I'm going to drop only time. From encoded train, to get the Y actuals, I'm only grabbing time. And then we'll do the same thing. From validate, we're not going to model on unencoded, we are modeling on unencoded, yeah? What columns do we drop? The target variable. What about test? Coded test. So now, if you've got X train, you're 3 lines of code away from X train that's clean, pre-processed, you're 3 lines away from code from being able to evaluate a model. So now we will, just so I don't have to type everything from scratch, I'm going to steal my modeling code. It's still the same baseline, right? It's the same data set. And notice where I moved away from the variable called encoded. I don't want to make an encoded train X because that's going straight into the model, and the model always needs encoded data, right? And then we can do a print out a classification report on train data, see how we're doing in sample, and then we can see how we're doing out of sample. So now let's evaluate out of sample results. And the results of the model are going to be the same because of the same hyperparameters. And we will say Y validate predictions is tree.predict X validate. And instead of Y train, we say Y validate. Instead of Y predictions, Y validate predictions. We still have a pretty darn good model, right? Nothing changed about the model's performance. This is a question of when you want to do pandas manipulation and where. One of these methods is not superior. You'll notice it was almost like we had to go around our elbow in both of them, but in different places, right? So there's not one that's perfect. Fred?
Just a question on the calculation of the X and Y sets.
Yeah.
X is the variables, Y is
You got it. You got it. Fred asked a clarifying question, folks, and I want to repeat it because it's a great question. To clarify, X, the capital X, is the independent variables? Yes. And to clarify, the Y is your dependent variable? That's absolutely the case. So independent variables are your inputs, your features. Dependent variable, that's your target variable. Yeah. And I'm not going to call this splitting. I'm going to just call that separating your X from your Y. Yeah. Andrew?
This might be a question for another time.
Sure.
Have you ever passed in more than one variable to your Y?
Yes,
More than what's right here.
yeah, we're not gonna do that here, but it's totally possible. Yeah. If you can believe it, making predictions on 2 columns is possible. Yeah. Cool. I'm gonna add, commit, and push my work, make sure that y'all have a copy of this. Again, there's not a wrong answer. The only wrong answer is freaking out and stopping coding, right? See, that's the only wrong answer. And if you gotta freak out and stop coding, that's what breaks are for, right? Take the dog for a walk. If you're downtown, take a walk around Travis Park. The river walk's over here. I find that the river walk is pretty good for debugging. Just going for a walk. Same thing, Travis Park is great for debugging.
I just had, okay, so I like the idea of the 2 separate data frames, just,
Oh, option 2? Yeah.
but some, like, when I ran into this, exercise, yeah, after, coding, to like, you know, because mentally you kind of have to like sit there and maybe do a little more work to determine what it is.
Mhm.
So would you maybe sometimes like label your column that you coded to help make it easy? So if
Yeah.
you wanted to keep it all in the same data frame.
Yeah.
you would start them all with coding or something that would like.
Yes. The get dummies is putting the name of the column underscore the value of that column, but we can overwrite these ourselves.
Yeah.
And this is kind of an option. If you want to do either of these options, instead of the smoker no, smoker yes, you could go in there and say encoded smoker no, encoded smoker yes. And this is that's another way of making the designation.
Find those columns live.
Yeah. Yeah. Instead of like manually poking through the columns and writing down what you're going to drop, you could programmatically say, do like a list comprehension or just a loop in a list. We say if for every column in the list of columns, if the column's name starts with encoded, handle it differently. Yeah.